Hello everyone, I am ATUL NEGI and I welcome you all to IMS Academy YouTube platform. So today we will be discussing flywheel topic in our Theory of Machine Foundation course. So this is our lecture number 2 on flywheel. Okay, till now we have discussed about the introduction part of the flywheel, where we have talked about the purpose and objective of the flywheel and how it is different with respect to governor. Right, we have discussed in detail regarding the basics of flywheel. What is the fundamental reason behind using flywheel, and what is the reason of using governors? Both the things we have discussed in detail. Right, I hope that basic part is clear to everyone. Right, so now in this particular session we will move ahead in this flywheel topic analysis, and we'll see how we can do further analysis part, and most importantly the fluctuation of energy that flywheel is going to control. That part we are going to discuss. Okay, so everyone try to understand here, like flywheel, in the case of flywheel, the main reason why we are using flywheel is because of the fluctuations. Okay, because of fluctuation in the turning moment. Right, because let's suppose 4-stroke engine we are having. So power we are getting in any one of the stroke, like power stroke we are getting suction, compression, and there is a power expansion where we are getting all the power, and then finally exhaust. So out of 4 in one stroke we are getting power, so there is non-uniformity. But at the end we want what? Uniformity in the power. So to get that uniformity we will be using this flywheel. So if you don't use flywheel, then there will be a fluctuation in the energy, and because of that what will happen? Fluctuation of speed will happen, and ultimately there will be what we have to suffer from those fluctuation of speed, right? Because there will be a jerk always. So in order to avoid those scenarios, we have to use flywheel here, right? So let's get started everyone, and before starting the session, just from my side there is a small advice from you for you. Join this Telegram group, guys. In this Telegram group you will be getting all latest job notifications, right? Daily quizzes will be conducting in this IMS Gate Academy Telegram group, and also the PDF, lecture PDFs of this sessions, whatever the sessions we are taking in YouTube, all lecture PDF you will be getting in this particular Telegram group. So you can join this particular Telegram group. Okay, and as I already told you, we have started our live online program, and in this live online program more than 800 hours of sessions will be there, which is totally interactive. In the live class itself you can interact with the faculty, ask your doubts. Okay, so there will be always an option that in the live class only you can discuss your doubts, and after that you will be getting GQB, Gate Question Book, exercise book, and theory books, and online test series is there where chapter level test, subject level test, and online full length tests are also available, right? So you can enroll in this live online GATE program, and main feature of this program is the mentorship sessions, which are totally one-to-one sessions where you and the faculty will be there, and you can discuss whatever the challenges you are facing, and faculty will help you, okay, so that you can overcome those challenges and whatever the problems you are facing in your GATE preparation part. So if you are interested in live online GATE program of IMS Gate Academy, you can directly call on these numbers. Okay, so our counseling team will help you how to enroll in this live online program. So next week we are starting our new batches, so you can directly call on this number to enroll in this IMS Gate Academy live online program for GATE preparation, right? So now let's get started with the flywheel topic. So I already discussed the basics part in the last session. Okay, basic part already discussed. So as I told you, there will be what? Fluctuations. Now let me tell you about the fluctuations part in the 4-stroke. Okay, this thing we have already discussed. Okay, like this. This will be the fluctuations we are having in the turning moment diagram. Turning moment diagram of a 4-stroke engine. Okay, four-stroke engine. Four-stroke engine, right? Now here the very basic point that you need to understand is, this is what the suction from 0 to pi there will be suction, pi to 2 pi there will be what, compression, and pi to 3 pi expansion we are having, and finally 3 pi to 4 pi exhaust. Okay, now you can see this is what the non-uniformity. But if I ask you the engine, okay, in order to overcome the load on the engine, we need a constant torque value. We need a constant torque value, but this is what we are getting, okay, from the engine. So in order to run an engine with a constant torque, okay, how we can use this kind of engine where this kind of fluctuations will be there? How we can use it? Because we want a constant torque value. In order to run an engine for a constant speed, we need what? Constant torque value. And if this kind of fluctuations will be there, it is very difficult to run an engine or any vehicle. So we want a constant torque value. Okay, so the mean resisting torque which is required to just overcome the load on the engine, there will be a mean resisting torque value which is what required by the engine to just overcome the load. So that mean resisting value of the torque we need to calculate here. Okay, so that basic fundamental part. First part of the analysis is what? Calculate the mean resisting torque value, okay, for which we can just overcome the load on the engine, right? So that mean resisting torque value we have to calculate. So let us assume the value, okay, so let us draw that value here. Okay, just a minute. Okay, let me draw it with this hand only. Directly I will draw as a mean resisting torque line I am drawing, right? This is the mean resisting torque. Okay. Now, very important point that we need to understand here is this is the mean resisting torque which is required by the engine to just overcome the load. And I've also told you this point. Okay. Whatever this area we are having above this mean torque line, whatever the area we are having above this mean torque line, that is what the excess energy produced by the engine. So that excess energy is going to what? Store in the flywheel. See, purpose of flywheel is what? To store excess amount of energy and release it back when it is required, right? So actually when I will install flywheel in the crankshaft, so that basic part you should understand. On the crankshaft, flywheel is going to install. So what actually flywheel does? It increases the inertia of the shaft. Okay, it increases the inertia. So as the inertia increases, it is difficult to rotate. Once it is rotated, then also means what? Difficult to stop also. If any body is having high inertia, it means very difficult to rotate it. Okay, with respect to rotation I am talking here. Because for crankshaft, we want what? Rotation. That's why in terms of rotation I am talking. So as high inertia it is having, so difficult to rotate. But once it started rotating, then it means it is difficult to stop that part also. Difficult to stop the rotation of the crankshaft. So that's why inertia of a crankshaft is increased by using the flywheel on the crankshaft. Okay, so that's why what happens? The kinetic energy is going to what? Stored in the flywheel. Which energy? Which this one, this excess form of energy, excess energy. Okay, and in the diagrams how you will find out? Just area above the mean torque. Area above the mean torque is what the excess energy we are having. So this point you should everyone remember, right? Okay. Now it is not necessary that always this kind of graph you will be getting, because this is for 4-stroke engine. Any diagram they can give you, any T theta diagram they can give, and for that they can ask the mean torque. So you should understand mean torque is the value of a torque or the mean resisting torque value for which engine is able to just overcome the load. Now, biggest question is what? How to calculate mean torque. Okay, so for that there will be some relations that I am going to tell you here. Okay, see. So I hope it is clear. So 0 to pi, as I already told you, suction, then pi to 2 pi compression, and pi to 3 pi expansion, 3 pi to 4 pi exhaust. So is it clear? Right, now. So one by one, those important relations we are going to write here. So the very first relation is what? Work done per cycle. Right, work done per cycle. So work done per cycle is what? Area of T theta diagram. Area of T theta diagram. Is it clear? Area of T theta diagram. Now this is a one way. Another way to calculate this work done per cycle is integration from 0 to theta. That theta will be the time period, obviously, because we should know at what angle the cycle is going to repeat. If I talk about this 4 stroke, after 4 pi again the cycle is going to repeat, right? So we need to know the time period. Okay, we need to know the time period here. So that's why this theta is what? The time period. So 0 to time period T d theta, if I do, I will get the work done per cycle. Okay, where this theta is what? Time period. Okay, fine. So this work done per cycle is area of T theta diagram, or using this relation also we can calculate. Now another way, okay, another way of writing. So let us write this as a second relation. Third relation. Okay, please understand. Third relation. Work done per cycle equals to mean torque. Okay, mean torque multiplied by theta. Theta will be again what? Time period here. Because whatever the energy engine is producing, that we are assuming, okay, we are assuming that that will be sufficient to run the engine. Whatever the total amount of energy the system is producing, the engine is producing, we are assuming that that much amount is what? Sufficient to run the engine. Okay, so that's why whatever the work done per cycle will be there, it will be equals to mean torque into theta. Theta is our time period. Again, this is very important point. Now, if you are able to calculate work done per cycle either of these ways, okay, so let's suppose mean torque we need to calculate. So either we can calculate area of T theta diagram. If proper diagram is given, we can calculate the area. Secondly, let's suppose area is not given, some torque expression they have given in terms of theta. We can do the integration and we'll get the work done per cycle. Once work done per cycle is calculated using this relation 1 and 2, then that work done per cycle I will equate with T mean multiplied by theta. So mean torque we can easily calculate. Okay, so using any of these two methods from relation 1 and 2, I can calculate work done per cycle, and using that value of work done per cycle, I can also calculate the mean torque. I hope this is clear. Now, why mean torque is important? Sometimes they will be asking calculate the power. So in order to calculate a power, we need to know the mean torque value. Okay, this is very important statement. So next statement will be what? How to calculate the mean torque here. Power. Basically, if I talk about power here, so that power will be equals to your mean torque multiplied by omega, and obviously this omega will be again omega average, or mean also we can say. Mean torque multiplied by omega average. This will be what? The power of an engine that engine is producing. So if in the question they have asked calculate the power that engine is producing, we can use this relation. Is this point clear? We can use this particular relation. Tell me everyone, is it clear? Okay, great, superb. So for 4-stroke guys, you need to understand, for 4-stroke the time period will be what? 4 pi. As you can see the cycle diagram here, after 4 pi the cycle is going to repeat. Okay, because in the 4-stroke 2 revolutions will be there. So time period is 4 pi. For a 2-stroke engine, what will be the time period? 2 pi. Okay, so this is very important. So this point also you should remember. So angle of crank rotation, after which again cycle is going to repeat. Okay, so after 4 pi again cycle is going to repeat, because entire 4-stroke is going to complete within this cycle. So after this again new cycle will repeat. That's why we always calculate work done per cycle. Per cycle how much work the engine is producing. That's why per cycle is calculation is what very important. Done. Okay. So time period also clear, 4 pi. For 2-stroke engine it will be 2 pi, because there only how many revolutions will happen? Only 1 revolution will happen. Okay, but in 4-stroke 2 revolutions will be there. Okay, fine. Now coming to the next expressions, coefficient of fluctuation of speed, that is what we are going to control here. Fluctuation of speed only we are going to control now, so we need to know how much percentage of the average value there will be a fluctuation. Let's suppose 100 RPM is the average speed. So out of 100, how much percent of 100 RPM there will be a fluctuations. Okay, so 102 let's suppose, or from 98 or 100 or 102, like that we can say. So there will be different calculation, different fluctuations will be there. For example, simple example I've taken here. 100 RPM is the mean value. Mean value I've taken as 100. So plus in the above side and plus in the minus side. So that is what the fluctuation. But if that fluctuation is more, then definitely we are going to what? We have to ensure that that fluctuation should reduce. If that much fluctuation is happening in the system, we need to think about, okay, how to decrease that fluctuations. Okay, so these are the very important point in the analysis. Fluctuation of speed, okay, fluctuation of energy, all these parameters, right? So let us start. Already for this relations we have discussed. Next we have coefficient of fluctuation. Coefficient of fluctuation of speed. Okay, now see everyone, it is first of all represented by CS. Okay, with this we can denote the coefficient of fluctuation of speed. Now how to calculate this value? It is equals to maximum value of omega minus omega minimum. Okay, so maximum minus minimum value, that is range, divided by the omega average. Or we can also use RPM here. Omega is what in radian per second. Omega is in radian per second. We can also use RPM. So in that case we will write Nmax N mean divided by N average, like this, CS value, right? So this is what the coefficient of fluctuation of speed, right? So this formula is very important, because next we are going to calculate the coefficient of fluctuation of energy, and after that fluctuation of energy also there is one relation we are going to develop, where you will see this coefficient of fluctuation of speed also. So that's why this relation is important, and sometimes directly in the question also it is given. Okay, next write down coefficient of fluctuation of energy. Okay, now in this case it is represented by CE. Again, formula is similar to that, coefficient of fluctuation of speed only, similar to that one. So it is equals to E max minus E mean divided by E average, divided by E average, right? Now, how to write this energy? Actually, in the flywheel case, we are concerned about this rotational kinetic energy. So, half I omega square. Now, where I is what the mass moment of inertia value. Mass moment of inertia. Mass moment of inertia value. Now, for different shapes, you should remember the different values of mass moment of inertia. Okay, for different shape, for ring, what is the mass moment of inertia value? For sphere, what is mass moment of inertia value? For disc, what is the mass moment of inertia value? So, like that, you should know for different shapes how to write the mass moment of inertia. Right. So, let me give you some examples also. But before that, you need to understand coefficient of fluctuation of speed, this formula, and coefficient of fluctuation of energy, this formula will be there. So, if I have to calculate E max, what I will be putting? Omega max. In order to calculate E mean, what I will put? Omega mean. Okay, minimum omega I will be putting in order to calculate minimum kinetic energy. So, E belongs to, energy belongs to what? The rotational kinetic energy we are talking about. We are talking about here rotational kinetic energy. Rotational kinetic energy. Clear, everyone? Okay, so some examples I will give you regarding the mass moment of inertia. Okay, now see. So, let us suppose this is the ring we are having. This is R1, this is R2. Okay, so this is the ring we are having. In that case, what is the mass moment of inertia value about this center point? See, mR1 square plus R2 square divided by 2 here. Now, let's suppose they have considered a ring and they have considered both inner radius and the outer radius are equivalent. Both the radius they have considered equivalent. So, in that case, the mass moment of inertia of the ring about the center point will be simply mR square. Right, because here it will be 2r square, that 2 will get cancelled out with this 2 which is in the denominator. So, mr square is the formula. So, mostly we will be using this formula, but if different radius are given, different radius, inner radius and outer radius, that for inner and outer radius I am talking about here. So, different radiuses are given, then we will use this formula. If one radius only it is given, so we will use this formula. Clear? So, this is what the approximate value, if both R1, R2 are approximately equal or equivalent, right? So, this is for the ring we are having. Now, let's suppose if we have a disc, in the case let's suppose we have a disc here. Okay, now see. So this is the disk we are having. Now for the disk, if I talk about the center point, so for center point, the mass moment of inertia value will be mr square by 2. About the center point will be mr square by 2. But let's suppose if I have to calculate about this point or any other point, let's suppose this is the point A. For that, what I need to use? Parallel axis theorem. I need to use parallel axis theorem, which is like this. About A I want to calculate, so first I will write center, about center I will write, then mr square by 2. Okay, mr square by 2. Why mr square? Because distance between the center to the point of consideration, distance is what? R. So that r square we have to do. So r is the distance that we have taken from the center to the point of consideration where I want to calculate the mass moment of inertia. So that point I am talking about. So point A is the point about which I want to calculate mass moment of inertia value. So at center it is mr square by 2 plus here it is mr square. So finally we will be getting 3 by 2 mr square, like this. So using parallel axis theorem you will be getting that value also about point A. Is it clear? So these formulas are very, very important for ring, for disk. Usually this kind of cases will be coming in our flywheel. Sometimes they will say there is a ring kind of flywheel or disk kind of thing is there. Okay, so you will find this kind of shapes. Is that clear, everyone? So let's suppose for other case example, other shapes also we should write. Okay, so let us write for we have written ring and disk. Next, let's suppose we are writing for a rod. If I have to write for rod, okay, for rod how I will write? See, about the center point, the mass moment of inertia value is ml square by 12. ml square by 12. Okay. Now at any other point if I have to calculate, for example this is the point A. Again parallel axis theorem I can use, and using parallel axis theorem what I will do, first about the center I need to write plus mass multiplied by the distance of the center point from the point where I want to calculate mass moment of inertia. So your point of consideration basically. So distance is what? L by 2, because extreme end I have taken L by 2 whole square. L by 2 whole square. Like this you will do, you will get the mass moment of inertia value about the center also and about the other point also using parallel axis theorem. Using parallel axis theorem, that also we can calculate very easily, right? So I hope till this point everyone is clear, like regarding how mass moment of inertia we should write. Now next parameter that I have to calculate is fluctuation of energy. So parameter number 7. Okay, fluctuation of energy. Fluctuation of energy. Okay, now see, it is represented by delta E. It will be equals to the maximum energy minus minimum. So that's how we are going to calculate, right? So that maximum minus minimum. So this is what the delta E value. Now we will just again further simplify this relation, so that we will be getting one final formula here. So we will further simplify it. Okay, So maximum energy, as it is a rotational kinetic energy, so I will be writing half I, that is mass moment of inertia, into omega max square minus half I omega minimum square, right? So let's suppose take the common part. Common part will be mass moment of inertia divided by 2. This is omega max square minus omega mean square, like this. So omega max minus omega mean square, that is a square minus b square formula, a plus b, a minus b I can apply. So it will be omega max plus omega mean multiplied by omega max minus omega mean, right? So a plus b, a minus b. Now one thing you can understand here, that let's suppose if I take this 2 here, okay, if I am writing, so let us suppose this was what, omega max, okay. So what I am trying to say here is, if I take this 2 in this denominator, omega max minus omega x plus omega mean divided by 2, it becomes what, omega average, right? Very easy part. Omega max plus omega mean divided by 2 means what, omega average. So what I will do, I will remove this 2 from here, okay, and put it here, okay. So just denominator 2 I have shifted here, okay, which was initially mass moment of inertia divided by 2. So that 2 I have written here only. So this become omega average. Now if you remember the coefficient of fluctuation of speed, how I have written omega max minus omega mean divided by omega average. Now can I use this relation here? Yes, omega max and omega mean is there, but omega average is not there. So what I will do, I will multiply and divide here by omega average, right? Multiply and divide by the omega average. Again, no problem in that. So omega max minus omega mean divided by omega average becomes what, CS, okay, and this omega max plus omega mean divided by 2 omega average, and this omega average multiplied will get omega average square. Omega average square I will be getting. So this is what the relation we are getting for coefficient of fluctuation of speed, right? Coefficient of fluctuation of speed we are getting like this. So now finally the formula we will be having is, so this one also let us write it here, okay. So let us write in the next slide, omega delta E, this mass moment of inertia, okay, mass moment of inertia, omega average square, and CS. So you should write IM omega square CS. So this is the formula we will be having. Finally we got the formula here, okay. So where IM is the mass moment of inertia, mass moment of inertia of flywheel, okay. Then omega average, omega average is average speed of rotation, average angular speed, and the CS is coefficient of fluctuation, right? like this. I hope all the parameters are clear here. So Im, mass moment of inertia of flywheel. Now very important point you should understand, flywheel is installed in the crankshaft, but usually flywheel mass moment of inertia value is very high compared to that crankshaft mass moment of inertia. So that's why we will be considering only the mass moment of inertia of the flywheel, not the entire system. Entire system means what? Crankshaft is also included in the system, because flywheel is installed in the crankshaft. Flywheel is mounted, see basically the point is flywheel is mounted on the crankshaft. Okay, we are considering the mass moment of inertia of flywheel only, but actually when I mount this flywheel on the crankshaft, mass moment of inertia of the complete system increases, right? Because it provides additional inertia to the crankshaft. But usually it has its own mass moment of inertia value very high compared to that crankshaft. That's why usually this one only we will be considering. Okay. So wherever it is there, so think in this mind, think about this point that always we are considering mass moment of inertia of flywheel, remaining other inertia value of the shaft itself is very less compared to this value. That's why it is generally ignored. So all the parameters I have mentioned here. Now what kind of questions they can ask from the in gate examinations? Until now what kind of questions actually asked? Okay, multiple questions can be framed, right? But if I talk about till now whatever question asked from this formula, mostly questions were from this formula only. Majority of the problems were from this formula. Now delta E value, let's suppose given, so they will be asking calculate the mass moment of inertia of flywheel required, or they can ask calculate the omega average of the flywheel, or they can ask the CS value, calculate the coefficient of fluctuation of energy, or sometimes they are not asking mass moment of inertia of flywheel, they are asking calculate the mass of flywheel required. Mass of flywheel required. In that case, how you will able to calculate the mass? In the formula there is no mass term. This is the mass moment of inertia. How to calculate mass value? So let us understand here. Mass moment of inertia can also be written as m multiplied by k square. Now what is k here? K is the radius of gyration. K is radius of gyration, right? So mass moment of inertia can also be expressed as m, that is mass, multiplied by k square, which is radius of gyration. So instead of putting Im, we can put directly this formula, and we can also calculate mass of flywheel required, because sometimes they will ask mass of flywheel required, or sometimes they will ask calculate the mass moment of inertia value. So this kind of two questions, or CS value or omega average value. Now in order to find all those values, we need to know delta E. We need to know the delta E value. So for how to calculate delta E value, the basic part comes to the basic part, maximum minus minimum. How to calculate maximum? Half I omega max square, half I omega mean square. Like that we can calculate delta E value also. So delta E is the fluctuation in the energy, okay, that engine is producing, right? And we need to control that fluctuation. For that only we are installing the flywheel. Okay, so now coming to the questions part, guys. Okay, let us see some questions that was asked in previous year. So this is the question in front of you for 2 marks. A flywheel connected to a punching machine, right, has to supply energy of 400 Newton meter while running at a mean angular speed 20 radian per second. If the total fluctuation of speed is not to exceed plus minus 2%, then mass of moment of inertia of flywheel required. Then calculate the mass moment of inertia. Okay, mass moment of inertia they are asking for the flywheel in kg meter square. They have provided already this point, that flywheel connected to a punching machine has to supply energy of 400 Newton meter. That is what the fluctuation value they have provided directly. Okay, so direct formula based question we are having here. Just directly use the formulas. So that delta E like this, I omega square Cs. Delta is provided, I m value we need to calculate, omega is also given. Now what about Cs? Now regarding Cs, this is very important. Sometimes we will do mistake in taking this value. It is mentioned plus minus 2. It means minus 2% to plus 2%. From minus 2% to plus 2% they have mentioned. So total value of Cs will be what? 4%, which means 0.04, and maximum time the mistake will happen here. We will not give the attention to this minus plus sign. From minus 2% to plus 2% they have mentioned. So in total, what is the percentage? 4%. And 4% means what? 0.04 value. 0.04 value. So that 0.04 value you will put here and you will get the answer of IM, that is mass moment of inertia. Do it fast everyone and tell me your answers. What will be your answers? Okay, do the calculation because this is very easy. IM value we need to calculate. Omega average square, that is 20 square. All the values were given directly. Cs value will be 0.04. 20 square will be what? 400. That will get cancelled out. So 1 divided by 0.04. So 1 divided by 0.04 means what? 100 divided by 4. 100 divided by 4 will be what? 25. So option A is the correct answer here. Kg meter square. So this is the correct answer here. Now moving to the next problem. Yes, again next problem here. Now here they have asked something different part here. See, focus on the question. Certain engine having an average speed of 1200 rpm. Okay, n average in terms of rpm they have provided, no issue, because if I have to calculate omega, 2 pi n by 60 formula I can use directly. Okay, a flywheel approximated as a solid disc, they have mentioned in the question itself ki we are considering flywheel as a solid disc, is required for keeping the fluctuation of speed within 2% about the average speed. This is very important. Fluctuation of speed within 2% of average. So fluctuation is what? Max minus minimum. So omega max minus omega mean is 2% of the average. So what is the value of Cs? 2% only, right? Very important. So if you have done mistake in interpreting the question only, you will take wrong data and you will get wrong answer, right? This is you need to understand. Fluctuation of kinetic energy per cycle is found to be 2 kilojoule. Directly delta E value they have given. What is the least possible mass of the flywheel if its diameter is not to exceed 1 meter? Diameter directly given and they are asking the mass. They are asking the mass. So put all those values in the formulas and you will direct answer here. Okay. So if I talk about the solution part, okay, first of all we need to write the given data. Given data is n average they have given. 1200 rpm. Flywheel is a solid disc. Okay, fluctuation is within 2% about the average speed. So Cs value is 2%, which is 0.02. Which is 0.02. Okay, fine. Fluctuation of kinetic energy delta E is 2 kilojoule they have given. Kilojoule it is given, right? Now what is the least possible mass of the flywheel if its diameter is not to exceed 1 meter? So diameter of flywheel is also given as 1 meter. So we need to put the diameter of flywheel as 1 meter. So what should be the mass? Okay, so we have the formula here for delta E. Omega average square into Cs. Now delta is 2 kilojoule, that is 2 into 10 to the power 3. Mass moment of inertia. Now as they have mentioned ki it is considered as a disc. Flywheel is considered as a disc. So we will write the mass moment of inertia accordingly, which is mr square by 2 multiplied by omega average. Instead of omega they have given RPM. So 1200 RPM they have provided. So 2 into pi into n, that is 1200 divided by 60. We need to do the square of it into CS, that is 0.02. So from here mass value we can easily get. Okay, radius will be what? Half of the dia. Dia is 1 meter, so radius will be 0.5. Radius will be 0.5 meter. Right? Okay. So put all those values and tell me your answers. What will be the answer here? Keeping in mind that radius value is 0.5. So options are available: 40, 51, 62, 73. Please solve everyone this question. What will be the answer here, everyone? Approximately 50.6, right? So you can cross check the data here. Okay, whatever answer you are getting, please cross check it. So option, if I check here, option B will be the correct answer here. Right, now as a note point you should write here, if I ask you what is the time period of sin theta or cos theta, what will be the time period? Time period will be 2 pi. Okay, time period answer will be 2 pi. But if I write sin n theta, it will be 2 pi by n. For example, sin, I am writing 3 theta, but you will write 2 pi divided by 3, like this. Is it clear? So for sin theta, cos theta, time period is what? 2 pi, but it is written n theta, so that n will be coming in the denominator. This information is very important. Why is it important? For example, let's suppose torque relation is given. Torque relation is given, then using the integration of t d theta, I can calculate the work done per cycle. And if I have calculated the work done per cycle, I can calculate the mean torque. And if mean torque I have calculated, I can also calculate the power. Okay, in order to calculate the power, we need what? Mean torque multiplied by the omega average. Right? So calculation of mean torque is very important, and for that calculation work done per cycle is required. And as I already told you, work done per cycle calculation requires what? Two relations. Two relations we are having. Either we can have area under the t theta diagram, or integration of torque expression, right? T theta, integration of t d theta if I do, I will get the work done per cycle, right? But for integration we need to know the time period. Time period we need to know, okay? Otherwise we can't integrate, because we need to know after what angle the cycle is going to repeat. We need to know that information. Without that information we can't do the integration part, right? So that's why this information is very, very important. Clear, everyone? Now coming to the next problem, okay? Yes, this is the next problem. Now here you will see torque exerted on the crankshaft of a two-stroke engine can be described as, this is what they have given. This is the torque expression, where theta is the crank angle as measured from the IDC, assuming resisting torque to be constant, power developed by the engine. Now power formula is what? The mean torque multiplied by omega average, multiplied by the omega average, right? Now how you will be able to calculate this power? For that, mean torque is required, developed by the engine at 100 RPM. So 100 rpm calculation is there, so accordingly I can calculate omega also, 2 pi n by 60. So that is not a problem here. Problem is what? The mean torque. Mean torque, how you will calculate? That is the question mark. In order to calculate mean torque, we have a formula: work done per cycle divided by this time period. Now, work done per cycle calculation also requires time period. So what is the time period here? So sin 2 theta, 2 pi by 2, cos theta also 2 pi by 2. So whenever torque expression is given and sin theta, cos theta terms are there, you need to do what? You need to take the LCM of the numerator and HCF of the denominator. LCM of the numerator and HCF of the denominator. Clear this point? Because for this sin 2 theta, time period will be 2 pi divided by 2, and for cos theta 2 pi divided by 2. So time period here is 2 pi by 2 and 2 pi by 2. Whatever the terms are there in the LCM, take the whatever the terms are there in numerator, take the LCM of that, and whatever the terms in denominator, take the HCF. LCM for the numerator and HCF for denominator, and you will get one answer for the time period of entire expression. If it is only sin theta term, then it is very easy. But here, apart from sin theta, cos theta, one more trigonometry function is there. So in that case, LCM of the numerator, HCF of denominator. Individual time period I will calculate. Individual time period of this expression, individual time period of this expression. Then for both the expressions, I will take numerators and write LCM. And for both the expressions, denominator I will take and write HCF. LCM divided by HCF will be what? Our time period here. So accordingly, you will get time period, you will calculate work done per cycle, then mean torque value you will put here, you will get the answer. Is that clear? So I hope you have understood how to approach this particular question. So I will give you this question as a homework in next session, that is on tomorrow. Tomorrow will be what? 17th. So in tomorrow's session, I am going to discuss the detailed solution of it, and we will solve all other PYQ questions as well. All other PYQ gate problems we are going to discuss in tomorrow's session, right? So till now in the flywheel analysis part, we have discussed the coefficient of fluctuation of speed, coefficient of fluctuation of energy, and fluctuation of energy formulas. Now once we have understood all these parameters, now we can directly start solving questions that actually came in the gate examination. So next session will be totally dedicated for the numericals of flywheel that came till now in the gate examinations. Whatever questions asked, we will be discussing in tomorrow's session, right? So I hope it is clear to everyone. If you have any doubt, please mention in the comment box. Definitely I will consider that part, and we will be discussing in more detail in the upcoming sessions. And I hope you are enjoying the lectures of this foundation course on theory of machine. So please share this sessions to your friend as well, okay, so that they will also get benefited. And in the foundation course, my intention here is to discuss the basic fundamental parts and also solve gate previous year questions. So once if you have gone through this fundamental series, this foundation course of theory of machine, you will never face challenge or any difficulty in whatever topics that we have discussed in this series, right? Okay, so I hope you will definitely get benefited from these sessions, and in the upcoming lectures also, after this flywheel, we will be starting our gears chapters also, then gyroscope, then balancing. So many topics we are going to discuss here. So please share these sessions to your college friends also, right? So thank you so much. Please don't miss tomorrow's session, where we actually solving gate previous year questions of flywheel. In detail analysis we are going to do each and every problem, right? Thank you so much. Bye bye. We'll meet you tomorrow's session.